All right, so let's continue with our analysis of the proper way to dimension and using an assembly drawing to derive the appropriate best dimensions for individual parts. We've already done the drawing for the top plate and the axle support, and now we're going to move on, and I think we should be able to do the last two parts here, that is to say the bushing and the wheel. We might be able to get them in one video, so I'm going to try to do that. So let's continue on. All right, so we go to design and drawing, and again we're going to select, and we'll do the bushing next. This is a metric drawing, and we'll stick with B size. We use the ASME standard. This is going to be a very simple drawing, right, because it's a very simple part. And I think we can even bump this up to 2 to 1. Now I already know that I want to do a section view of this, right? That's obviously what makes sense. I shouldn't say obvious, but and I want my I'm going to do a back view here, right? Sorry. Let's do let's look at a left view. No, let's look at a right view. There we go. That's what we want. All right, so that's going to be our front view. And if you're wondering where the heck I'm going with this, you'll see. So I got my front view in there, and now I want my section view. And my section view is going to be right through there, and it's going to be that view right there. Okay, and we don't need that again. All right, so very simple part. Let's put our center mark in there, and let's put this center line in there. All right. So this is basically one negative cylinder and two positive cylinders, right? So from a size point of view, we dimension holes, negative cylinder, we dimension holes in their circular view with a diameter. So this is the circular view of that. There we go. And we dimension cylinders in their rectangular view with a, diameter, right? Now, notice we have to use a linear dimension here. So, we can't use a diameter because that's looking for a circle. So we go like this and like this. We go there. And you cannot forget to put the diameter symbol in there. Right? That's important. And let's do this. And we'll get that in there. Okay. And then cylinders need thicknesses. Okay. And here's where we can make sure that we are including mating part dimensions. The thickness of this part right here, and I'll put that dimension in here. The thickness here is derived from or mating with the thickness right there. So mating dimension, we want that thickness. And we probably should also have an overall thickness. Now, what are our options here? Let's just put our options. Once we determine that the 12 is what we want, what are the other dimensions that we might choose from? Well, we got the 19, and we got this dimension right here, which is the 7. Okay? So remember, if we put all of these dimensions in here, then we're guilty of over-dimensioning. So we can't have the 12, the 19, and the 7. Right? That's over-dimensioning. So we need to get rid of one of these. And we've already decided that the 12 is important because that's a mating dimension. Because it is also shown in this view, right? And so that's important. And it becomes more important once you get into tolerancing. So I'm kind of leaving out some bits about why it's important and exactly how it's important. But You'll just have to trust me on that. That once you start to apply tolerances to it, both dimensional and geometric tolerances, mating dimensions are absolutely critical. Okay, so we need the 12, but which one of these, the 19 or the 7? Okay, so let's go to the assembly and let's look at the view right here. Okay, so the shoulder, or not really the shoulder, the flange of the bushing is important because that is going to determine how far this goes into the area where the axle and the wheel are going to reside. But in the same breath, the total, I think this is, I think the shoulder here is going to be important. I think that's where we want to go, the 7 right there. All right. And so what I'm going to do is I'm going to, because I still want that 19, I still feel like that's important. I'm going to put this as a reference dimension. All right. Now remember, we're allowed to do that, right? That's one of the things that helps us to avoid over dimensioning. But now I want to put that 7 back in there from here to here. There, just like that. Okay. And that is it. Okay. So nice, simple part, right? Not a big deal. I'll just omit the notes right now, right? Obviously there would be notes here, right? But I'm just going to omit them. There's no fillets and rounds that we need. And so that is the bushing. All right, let's look at the. Oh, you know what? I forgot about the axle and the wheel. Let's do the axle next. So we'll go here, drawing, and maybe we'll save the wheel for the last one. And we'll choose that. Use ASME, we'll go like this. And I think we can bump this up to 2:1 also. All right, this is going to be a single view drawing. We do not need a side view of an axle, of this axle in particular, right? It's a very simple part. We don't need to complicate things, so we'll put the center mark in there. Center line, I should say. And we'll stretch that out. And we'll stretch that out. Now, dimensioning this. It is, generally speaking, it is always good to have an overall dimension for a shaft. All right, so we'll put that in there. All right. Now, how else do we want to dimension this? Now, it might look pretty straightforward, and I'm going to put in all the dimensions right now, just so you can see. Okay, so those are all the dimensions, minus the diameters, right? I'll put in the diameters. So the lengths. Now, again, this is over-dimensioning. I cannot have the 20, the 40, the 20, and the 80 all in there. All right, that's too many. We've already determined that the 80 is good to have because that's an overall dimension, right? If we need to cut it from stock, it tells us how much stock we need. But which one of these dimensions, the 20, the 40, or the other 20, do we want to keep or do we need? Well, let's go back to our assembly. All right, and let's look at this. All right, and maybe I will hide the axle support and the bushing. Or maybe I won't hide that bushing. Let's do the axle support on the other side. All right. And you can see that really the critical issue is, do I have enough room for the bushing on this turned down part of the axle, this decrease in diameter on the left and on the right? I need to make sure that I have enough room for my bushing in there. All right. The wheel is just going to ride on that, and there's a little bit of slop here and a little bit of extra space over here. So I'm going to make the decision that the 40 is unnecessary. And I'm going to keep the 20 and the 20 because that is going to be a mating dimension with my 19 for my bushing. All right. Now, mating dimensions don't have to be the same dimension. It doesn't have to be 19 or 20 here. But it's the feature that is mating. We have a positive and a negative feature that are mating, kind of like a pin and a hole go together, which we have right there. All right. So that's good. And I guess the last thing that we need is just the diameters, right? So, we'll dimension, we got to dimension these with linear dimensions, right? Because of what they are. And we don't want to do that, right? That's not good. So we want to pull that out. And I'll just pull this out to the middle because that's about good. And we want to make this a diameter. And we want to go and do the same thing to the other side here. Now here, we want to make sure that we, first of all, say 2x for 2 times and then add the diameter symbol. Right? Because there's 2 of these diameters over there. And it's not obvious that they're the same. The last thing that I need in here is a chamfer, and I could put that in as a note. I could also use a leader. I don't know what the chamfer, I think it's 2 millimeters, so I'll check it right here. 2 millimeters, yeah. So that's 2 millimeters. So, you know, I could just use a leader to dimension that, and I'll put it right there. Put it there, and we'll say 2. Now, this is always confusing to people. 2 times, which means it's on both sides, on the left and on the right, right and left, right and left, all right? And then the chamfer note is 2, because 2 millimeters, by 45 degrees, right? Now, for some people, that's confusing, right? And I agree, it can be a little confusing. The 2 times is not because we have a chamfer here and a chamfer here, right? This is a cylindrical feature. This is one chamfer going around a circle, going around a cylinder. So this is 1 chamfer, 2 chamfers. And that's what that 2, no space, x is for. And then we have the 2 by. Remember, that, and this is in a presentation that is in for the dimensioning. When we have a space between the x stands for by. So it's 2 millimeters by 45 degrees. When we have no space, it's a multiplier. So it's 2 times. 2 objects, 2 millimeters by 45 degrees. Okay. So there we go. All right. So that's done. Let's save this. And we'll go axle. All right, and let's just do the last one. We'll do the wheel so that we're done. The wheel is going to be pretty straightforward too. Select the wheel, SME. All right, we're going to use a section view with this as well because there's a lot of internal detail. I think we can get up to 1-to-1. This is not what I want for my base view, right? So I'll choose right view right here, and we'll put that there because I want a section view developed from this view. Right there. All right. Now, this is a series of cylinders and holes again, kind of like the bushing, right? So let's first put our center mark in there. There we go. All right, and Now let's start to dimension. We'll do the size features first. So the size of the hole, we can dimension that in a circular view with a diameter. Okay, and that's the only hole. So we have a cylinder now, the outer diameter here. And generally speaking, it's better to dimension between views. It makes looking at the views a little bit easier to understand. We'll dimension this as well. The main difficulty on this drawing is how to handle this angle right here, right? Fillets and rounds, we're just going to have a note, so I'm not even going to worry about dimensioning that. Oh, you know what I did forget, though? I did forget this right there. We can't forget that. And now we need a thickness. So we'll do a linear dimension right here. There we go. And let's go ahead and put in the diameter symbols, because that's something that I sometimes forget. There we go. And the last thing we need to get, we need the thickness of this part, right? So, here to here, and that's 10. Now, you might want to watch the symmetry of this, right? So we might want to put a center line down this to, clearly indicate that the wheel is intended to be symmetrical between the left and the right side. Okay. I'm not going to put that in there. And instead, what I'm going to do is explicitly dimension across that. So I'm not going to use symmetry on this one. And let's pull this out here. Yeah, it doesn't want to do that. Huh. There we go. Okay. It's good to have them line up. That's better. So leaving that one open is good. And then the last thing is, how do we handle this little angle here? Well, we need to give a thickness of this part here. Right, that's 3. And then we have, what we really have in here is an extended angle, right? So we want to extend this edge using the edge extension right there. And then we want a dimension between that. Now this is kind of an advanced thing. You kind of have to know how this is manufactured, and this would be a cast part. So that, fillet in there would be, from a cast, from the casting process. Now, obviously this is not good. The 3 is right in the middle of the 5. So what I'm going to do is I'm going to get rid of the 3. And I'm going to move it to the other side. Because we can do that to simplify the drawing. There we go. All right, and that is all she wrote on that one. All right, so again, pretty straightforward drawing. I think I got everything. Again, there would be notes here, specifically for fillets and rounds, but I'm just going to leave that out for right now. I got all the other dimensions in there that I need, size and location, and so that's done. And we have finished our detail drawings for the caster assembly. All right. So that, hopefully that paints a clear picture of how you go through these drawings, these parts, and create these detail drawings. Always keeping in mind functional attributes of the part, Like how do they function in the assembly? Where does the part live? Location is also so that important, so that we can make use of mating dimensions, mating part dimensions, functional dimensions. All that is absolutely critical. Absolutely critical. All right. So I hope that helps. Please let me know if you have any questions. Goodbye.